Okay, I'm recording now. And I'm gonna share the screen. Now this is UTAPWeLS. And this is the folder that you guys received. And the exercise that we're gonna be working on right now is this constructing a simple model and view. So you can click on it to see it. And I'm gonna leave it here so we can see what we're doing. We're starting from UTAPWeLS, the main window. And the very first thing that I am going to do, just to make everything go as smoothly as possible, I'm going to save the project. And I click save the project as. You can see that it gives you all these untitled projects. They're just generated automatically. I have plenty because I've been using it for a while. Yours probably will be untitled 1, and then just select whatever you want to save it. Just going to save it in the desktop. It's going to call it workshop. You can give it whatever name you want and save. In general, it's a good idea to save every now and then. Now, once you've done that, the very first thing you want to do is add a well. And the way you do it is with this yellow icon that we have here, add well.
I'd like to also say regarding saving, it's a good idea if you have a big project that you've been working on a while to keep backup copy. Like anytime it's working and you're at a state where you feel it's that you want to, then you're going to do some new things on it. Maybe save it to a backup copy or something. Because every now and then a project will get corrupted or something. It's good to have something to go back to where you don't have to start over. And so and sometimes it's even good if you're going to go different directions from the same starting point to have the project saved. So and also sometimes projects can get really big, and it's useful to save it at different stages, and or to save different things that you've done as different projects, just so you don't get too big of a project. And I think we'll see more of that later, but I just want to mention that.
Yeah. We had a very sad story before the consortium. One of the people that was preparing a big project had the project crashed just the day before he was supposed to deliver it. He had saved images and everything, but he lost like 3 days worth of work, and it was not even UTAPWeLS. He had not. What had happened with him is he had been working in this very large project for a long time, never closing it. And with MATLAB, there's issues with memory, the way it handles memory. It can run out of memory much sooner than. Somebody wanted to make a comment? No. Anyway, so he ran out of memory, and when he tried to save, it didn't have enough memory, and the whole project was corrupt. So he lost 3 days worth of work. So save regularly, like Bruce said, and not just with UTAPWeLS, but in general with MATLAB. Don't leave it open for more than a day. No more than a day. Yeah, that's what I would recommend.
Well, and I guess another thing, I mean, not just save regularly to save the project, but to save sometimes as different projects, because that will help keep the size of the project down. It'll make them load faster, make things work better. It gives you more flexibility also.
Yeah, multiple copies, sure. Yep. All right. So now we added a well, and this is what it looks like, the well interpreter. I hope this is just one step. I hope everybody's still here. If at any point you get left behind, just let me know. Now, what we're gonna do is we want to see some data. So the very first thing we're gonna do is in the well, we're gonna load this sample last file. So I just click here. It opens up this window where we have to click on this one again. And then we go to the folder, to the workshop materials that you have. And we have these are the LAS files, and it's asking us to get the sample LAS file. And there you go. And now here we have all the logs that we have, the description, the units, and whether you want to import them or not. In most cases, you will just want to import them all. Tells you the interval, and just click import. Now you have the data, and you can see that reflected here. Within the well in the data tree, you have within the log set, you have the sample LAS, and you have each of the logs. And if you click in any of them, it tells you a little more information here. It's the caliper, the data size, the depth range, the units, the min, max, mean, standard deviation, so on. Just quick interrogation of the data. And also you notice that here the gamma ray shows up, just to give you a reference of where you're at in your project. Now that we have loaded the data, what we want to do is we're going to plot what we have. And this is going to be different from how we used to do it, because we've modified the templates. So by default, you have the measured depth in the very first track, and then you have the boundaries that, because we're in UTAPWeLS, we use them pretty frequently. So in this track, we're going to plot also the gamma ray, but we're going to do it using the mnemonic groups. So to add any plot, the first thing you do is you click here, add log. Here you have all the different types of plots that you can add. You have the log, you have the shade, numeric. These three are the ones that you're probably going to use the most. Then you have the formation zones that we'll use at some point. And then these are more advanced that we'll go into them whenever they're related to specific tools. And then this one is, you will use a little more, the add vertical cross section, the one that has 4 quadrants, let's say. And then the very last one you might use a little more is the volumetric composition. It's the mineral composition. And now that we added another plot, we have the Earth model as type, and here we have the boundaries that we've added. Now, instead of Earth model, we can have mnemonics group, or we can have LAS. What we used to do is just go with LAS because we loaded one of them. The only option that we have for set is this. And then the first one we want to see the gamma ray, and there it is. That's it. That's one way. Now, a more advanced way to do it is using the mnemonic group, and by default goes to gamma ray, so there's not much to do here. You already have it will go to that one, and the curve is GR. Let's change the color here. Well, these are all the things that you can do to modify it. Sorry. I'm sorry, it's not letting me. It's not letting me do anything. I don't know why. Oh, because the color is already out. That's why it's not letting me anything. So now that I have the color selection, I can select green just to make it look more like we're used to. And here you have all the possibilities. You can change the limits. You can flip the limits. You can wrap the plot. If you're, for example, if you're short, you need more space, you can wrap. So let's see, you see the whole thing. You can reset the limits. That turns out to be pretty useful. You can change the style. You can change the width. You can add markers. In this case, it's not very useful because there's too much data, but in core data in particular, it's very useful to have a marker. So now we've added the gamma ray. Then it's then in the next, we're going to add another track. You click here in the add track, and you click here again to add the plot, and we're going to keep the boundaries, and we're going to add another one that is going to be a neutron porosity. I'm going to do it also through the mnemonics group and neutron porosity. Now, the problem I have here is that there's no data available because the mnemonic group does not include the CN as a name for, as a curve name for neutron porosity. So I have to click here in edit mnemonic group, this button next to mnemonic type, and it opens in neutron porosity because I already have selected neutron porosity. And these are the curve names that I have, but I do not have CN. So I have to add CN, enter. Now I've had it, and now I have it here. I say okay, and I have to select it again. But once I select it, well, and I have to neutron porosity. I have to select something else and then go back to neutron porosity. And I'm gonna switch here. The units are not recognized, but that's okay. 0 to 0.4 or 0.4 to 0. Now I have the, anybody had issues with that? If you have any problems, let me know. What we did is, remember, we have instead of selecting specifically the LAS, we're saving this as a more general mnemonic, so that if you open this in another log, you will be able to see this, even if the same, even if it's a different curve, but it's still within the mnemonics, within the neutron porosity mnemonic group. That's a mouthful. Then now the next thing we're going to do is we're going to add resistivities, and it's 3 of them that we're going to add. So it's another track, and again boundaries, and then here I'm going to do it also as a mnemonic group, and we're asked to do it for sorry, shallow, medium, and deep resistivity. So I'm going to start with shallow, and by default you do have shallow resistivity, but the curve, the specific curve that we need, we do not have it. So again, I have to add it here. So it's M0 R1. Okay, and just select something else and then select shallow resistivity. Now there it is. I'm going to do the same, but for medium resistivity. We don't even have it as a mnemonic, so we have to click here, and in the mnemonic groups, you have 2 buttons in the bottom of the plot or the figure. You have defaults that make sure that at least the default mnemonics that we have generated are present in case you deleted some. And this is to add a new group. So I want to add a new group, and I want to give it a different name. It's going to be medium resistivity, and it's going to be, the type is going to be LAS. It could be any, could be simulated. If you want to make a distinction between these two, this is where you would do it. I want to make sure it's not simulated. And the names for this one, I only have one so far, MOR1, capital R. And I say, okay, now I have medium resistivity. Now I just, I need to close and open. And now I have medium resistivity here. Oh, sorry, I made a mistake. Instead of MOR1, it needs to be MOR3. And it's good that it's still telling you which one did it actually find. Medium resistivity, MOR3. Nice. Is everybody here?
Excuse me. I guess I have a basic problem here. I don't see type when I'm going to add a log. It doesn't let me choose the mnemonic here. I have only Earth model, LAS, and simulated log. I don't have that.
You might have an older version of the software.
Oh,
But that's okay. In your case, it's okay. You can do most of the things we can do. You can do. Do you know which version is it?
how do I get that?
You can. Yeah, that's a good. It's a good opportunity. Here in help, you have the about, and mine is version 5. Well, it's not really version 5. It's just the developing version, but in yours it will have the number.
Yeah, it's 4.84.
84. Yeah, we had not added that part. But that's okay. In your case or anybody else that do not have the mnemonics, you can just say LAS. So it's going to be faster for these, but it's not as reusable. So you just do LAS, and then you select. You have the specific logs. So you just select MOR3.
Okay.
Yeah. I'm gonna stay with the mnemonics though, but you know how to do it. And then the last one is deep resistivity. And that one, I already had the MOR9. And now this is how my actual plot looks like. I have all three here. They have 3 different colors, but I cannot tell them apart very well. I'm a little colorblind, so I'm gonna change this one a little bit. The color goes behind. I don't know where it went. It goes, I see. It goes behind the Zoom tech window that I have with you guys. So that's why I cannot find it. But so I minimize you, and it should be okay. So I'm changing it to a color that I can tell apart a little better. Maybe, yeah, that color is fine. And here in the color map, you can expand it also. By the way, you'll have more options if you prefer. So I have these 3, and this last one, I'll make it orange. Just 3 colors that I can tell apart, but it's fine. Now, with resistivity, of course, you don't want the scale to be linear, so you can change it here to logarithmic. And you can change the offset, and you can change the number of decades. In this example, the offset that I have is 1, and I have 3 decades, but the left limit for each one is at 1. So 1 to 1,000, yeah. And something you can do is you can modify the limit just in one. See the left offset and the number of decades is going to apply to every single plot, but the left limit is independent for each one. So what I can do is I can go in here and right click in the legend of the plot that has the limits that I want to use for everything. And then I get a number of options, but the one I'm interested in is this snap meter logs to the limits for this plot. And I click that and makes all the limits be the same. And now we have it here. Now, because resistivity is a little shorter, well, we can play with we have a number of limits that we use here that we're playing with. We have the viewing limits. We have this we call the reference track, and the reference track has some limits that we can play with. And then we have the modeling limits, which are the limits that we're going to use whenever we run a simulation or whenever we run a calculation. So we reduce those limits to the area of interest. But here, for example, and you can set all 3 of them here. If you right click in the reference track, you can modify them. And also the viewing limits, for example, you can modify them here. Well, this is this green line that you see, green dashed line is the modeling limit. And this becomes a bar that you can modify the viewing limits also. So if you don't want to see what the part that resistivity is not doesn't have any data, you can reduce that or reduce it even more. This is totally up to you. And then if you we also have here the controls in the top left, the third row, we have these controls. The first one is the one that opens the track editor that we've been working with. As you saw, you can also open it just by double clicking anywhere. Then the second one gives you options for the view or the track display general view. You have the style. Right now it's compact. We can make it a little more expanded if some people prefer that. You can change the color. You can change the track lines. You can customize it as you will over here. Then these three are for moving around. So the zoom, if you want to zoom in, you can drag the lens into a specific section. For example, this might be interesting, so you can zoom into that. If you double click, it goes out to the modeling interval. You have the zoom out, of course, and also if you double click, and you have pan. Doesn't make any sense unless you're zooming in. And then you can pan if you want to go around slowly and see your data in different parts. And you have the viewing limit here. You can also scroll this way. You can also use your scroll wheel to go up and down and modify this as you will. That's just so you how you move around your data. Well, and we also have the standard view, 1 to 5 and so on. This just it's just going to mean that one inch of screen is 500 inches in the well. So some people are used to these scales. They are familiar with certain scale, and they know they get their mind around this scale a little more easily. So you can use them yourself. I'm gonna stay with this large view. Right. If you have any questions at any moment, feel free to unmute yourself and talk, by the way. Okay, so now that we have our plots, what we want to do is modify the titles of each track to be something meaningful. What that means is that here in the track editor, in the top right, you have this title window where, for example, the number 2, where we have gamma ray, I'm gonna call it gamma ray. It looks a little better. Then here I go to number 3, where we have neutron porosity. So I'm gonna be very creative and call it neutron porosity. And then number 5, we have resistivity. Now they have a title too. It's a lot easier to see what it looks a little better. That's it. Now the scale of resistivity, we have already done the scale of resistivity. Then just for those that have the version that already includes the templates, we're gonna turn this into a template that we can reuse. To do that, we just say new template. Don't do new clean template, because it will, well, you can do it, but it's just not going to carry what you have already. You would have to go back to default and then do new clean new template. Notice you have two drop-down menus here. The first one is to go around different. So if I go back to default, this is going to go back to what I had, which is the exact same thing. I have some other. I've done these templates in the past. I have gamma ray and resistivity, but right now I made template 1, so we're sticking to that one. And then you have the template manager. So this template 1, I'm going to call workshop. You can give it any name you want. And now I can reuse it across wells. And I can say save in user settings, which means that it's going to be saved in your computer in your user settings. That's, you have a file in your computer where some of the information that you're using is going to be saved. That makes it not project independent, so that whenever you're working a different project, it's also going to be there. So I just click here and it's going to save it and update it everywhere else. And you can share it with other people and so on. And you have the revert if you want to go back to the other version. That is possible for, I think, even for if you didn't have the mnemonics, you should have the templates in 484. You already have templates, so you should be able to do this part. That's it. Okay, so now that we've saved the template, we kind of reuse it in other wells. Now we have pretty much exactly what we were supposed to have here, and you can just this image is just to confirm that it looks the same. Now we're gonna start working with the Earth model itself. So the first thing we're gonna do is we want to add some boundaries, and in general, you can do it by hand, and the way you do it by hand, you have here, or manually, I should say, you have these 4 controls: the create new petrophysical boundary, create new property boundary, delete boundary, and move boundaries. The difference between a petrophysical boundary and a property boundary is that property boundaries are like fluid boundaries. Petrophysical boundaries set different distinctions between rock petrophysical properties, for example, porosity and so on. Every property is going to be modified, is going to be changing across a petrophysical boundary. Across a physical boundary, it's going to be only properties that are related to fluids. So, for example, resistivity or water saturation, they can change along property boundaries. And the reason why we have these two is because when you do invasion, you have petrophysical layers, and then it's easier to work with them independently from each individual grid point that you're going to have when you run invasion. So, well, so that's the main reason why we have them. And we also have, well, we're going to see that we also have radial zones, and they have the same distinction. So we could add, if I click here and add petrophysical boundary, part of the take-home lesson, or the minimum thing you should know is, if you're in doubt about which boundary to use, which type of boundary to use, just go with petrophysical, because everything can vary across them. So it's a lot easier. If in doubt, just use petrophysical, and you can just click here and just now you can add them anywhere you want. This is one way. It might be a little tedious. You might be missing stuff, but it gets the job done. And then you can delete them, or you can adjust them if you think that they're a little off, and you can delete them. Just click there, delete, or you can click, drag, and delete multiple simultaneously. And now these two other buttons are undo. So now I get those two back, or redo. Now it goes, those two get deleted again. Just undo, redo. Now, because that process could be a little tedious, what we're going to do is we're going to open this module called detect boundaries, and you open it either with this menu that says detect boundaries, the one that has the two blue lines, or within the menus you have Earth model, and within within Earth model you have detect boundaries, and it opens up this module. And what this module does is it takes a certain log that you choose and uses certain rules to decide whether there's a boundary or not. In this case, we're going to use gamma ray. Just double click there, and it tells you here the logs that you're going to use to detect the boundaries. So we're just going to use gamma ray, and it asks you if you want to detect physical boundaries or property boundaries. So because it's gamma ray, we're going to use it for the detect physical boundaries. Then it's asking me if I want to keep existing boundaries, because I already have some boundaries that I'm not sure they're right. I'm going to uncheck this to not keep any boundaries. So it's going to redo everything. And then the rules that I have are here. We have the maximum variance, which is the most common one. Here, if you scroll over them, these little menus that you see, they're called the tooltip menus. So the tooltip menu is going to tell you what it does. It calculates the variance of the logs within sliding window and picks the maximum extreme second difference. Well, there's maximum second difference that has the other options. Pick the points between the maximum and second difference, and here it's easier to see if you click in this help menu. It gives you the same information, but it's a lot easier to see. And it's just the definitions of how it's done. In general, the maximum variance is going to be whenever you have the transition between positive and negative slope. So it's a lot easier it's the most common. So just maximum variance is probably the best, and has a noise threshold and a sliding window size, so that it calculates the variance associated to each point, depending on just using the points within that sliding window. The noise threshold. So just using the default values, I click detect boundaries, and I'm getting 474 boundaries. I can see that as I move around the track display, in the bottom over here, you can see some information, some status display of where the mouse is. So for example, right now it's just the measured depth, the value of the gamma ray. Any logs that you have in that track they're gonna show down there, and it's telling me that I'm in the layer 322. And if I go to the very bottom, and because everything is petrophysical layers, the layer and petrophysical layer indexes are going to be the same. If I go to the very bottom, it's saying 474. So it's a little too much. It's not necessarily that we cannot handle this, but it's not going to be as good. So maybe the noise needs to be a little less. So I'm turning into 0.1, and I'm not keeping the previous one. So make sure you uncheck this. I hit detect boundaries, and now it's looking a little better. I'm going to zoom in into some areas to see. It's a little better. There's some that are it's probably finding a little too many in some cases. You probably don't need these two. One is enough. There's some cases where it's still finding too many. I'm gonna make the noise threshold a little larger, maybe 0.2. That's looking better. And now the slide, because I can see this area, this looks fine, but this area over here, there's clearly a little too many. And the problem is now you see the data and they look okay. Well, some of them, this might be not. So I'm going to make the window size a little bigger. So 2 and 0.2, maybe 3 and 0.2. And I'm going to just settle with 3 and, let's say 3 and 0.3. Let's see what we get. At some point, you just have to say, okay, this is fine. And you have to say this is fine, and I can improve it myself. So for example, here I can see that there's clearly one missing. So I'm just going to add it. There's probably another one missing here. I'm going to add those. Then here, there's probably too many. Here, there's probably one missing, probably two missing. So, and this is very much up to you. I'm not expecting everybody to have the exact same answers. So it's okay. Everyone's going to have a slightly different interpretation. Over here, I mean, they look okay. I'm going to leave them all. You see some interesting features down here. Here, these ones probably a little an overkill, so I'm going to get rid of one. I don't know what's going on here. Anyway, it doesn't have to be perfect right now when you actually use it for something that has more practical applications. Needs to be more accurate. For this introduction, this is fine.
Joaquin,
Yep.
just a thought. What if we can play with the filters to see if the filter log might help in detecting the bit boundary?
Yeah. That's a good idea, and let's do it. So what you do is you go here in filter logs. You access it here either directly by this icon or logs, and then the very last item in the filter logs menu will bring the same window. Let's do it using the gamma ray because that's the one we were using. This is it. And then the name of the output is going to be filter low pass. It tells you the name of the filter and the type. For people that electrical engineers and people that really know about signal filters, they can have a blast over here. It's very interesting, and it's also a very good, like many things in UTAPWeLS, it's very good if you're teaching a class in this topic. But for now, I'm in most well, we have low pass, band pass, high pass, and so on. In most cases, you want a low pass, meaning that you want to get rid of the high frequency signal, which in reality is not a signal, it's just noise. The noise has a higher frequency, so we have a low pass. And you can interactively, well, here's the magnitude of the frequency and the phase. So you can either move the low cut of the frequency here just by typing 0.3 or whatever, or it's easier if you just move it around and see how it responds. It's probably interesting to see a little closer. It doesn't seem to have a lot of noise. It seems like it's yeah, it seems like it's just, even with the highest threshold, it doesn't seem to be getting rid of much. So it's going to give us a very similar answer. If we were to do the opposite, it looks very different. Of course, it's but you would never do a high pass in this low pass. And you can change the function that you use.
Joaquin,
Uh-huh.
Just a small question. I remember asking this the last time, but I don't really remember the answer. Can we use anyhow image logs, importing and using this in the boundary determination?
We don't have it for boundary detection. No, you can just use them to guide yourself by clicking, but we don't have an automatic picker. No.
Okay, but can we import DLI's data with image logs?
It's a little more convoluted than that. We cannot import. We do not work directly with arrays, so you have to turn them into an LAS. No, you have to make sure that each segment of the image is an independent channel. So the quick answer is yes. The more elaborate answer is yes, but it's not that straightforward. So you have to make sure that each segment in the azimuthal direction is a different channel, and then you have to turn it into an image. But yes, it is possible.
Okay. Thanks.
Send me an email and we can do that. Anyway, just the filter. I'm just gonna, just for completion, even though it's not filtering a lot, we can let's see another. Let's say that the deep resistivity we think could be interesting. I'm gonna use both. Let's see how it looks like. just to see the effect. Anyway, let's go back to what we were doing. But yeah, this is it's an option for sure. And once you are happy with the filter selections that you've done, you can just save filtered log. And in the log set, you would have gamma ray, low pass, Butterworth. And you could use it in here, but in this case, it's gonna look the same. Now we have it here, but it's gonna be the same. Now let's say that we're happy with what we have here with the boundaries that we added and everything. So the next thing we're going to do is we're going to see. Sorry, I'm skipping points. We're gonna set up some invasion and some borehole profile. Now to do that, we're going to calculate the borehole diameter so that we can use, well, using the caliper, and we're gonna then use that diameter log to put it in the Earth model. So the first thing to do that is to go here in where it says logs, custom log calculations, and you'll get this window. And we're going to do a custom calculation. To do that, you just click in the bottom panel. There's no specific place where you need to click on. Just click on that panel. And we're going to name our RAD, radius, or radius, whatever you want to call it, the output log. And it's going to be the caliper divided by 2. Now, to make sure we have the caliper here, we need to set it up here. This table is just a table that takes the log sets that you have and the logs. In this case, I'm interested in the caliper, so I select caliper, and it gives it a unique name. This is just in case there's multiple logs with the same name. You want to make sure that is the one from the log set and the one you decide you need to use. That's the only reason why we need this extra step. And then we just divide it by 2. And we can select the output units by either selecting here inches, or notice you can also just type in or inches, or in is fine. And now that we've done that, that's going to give us a radius. We just calculate. Nothing shows because it's so quick, but it's done. And again, you can see that it's done because here now we have the radius and tells you the units that you have and so on. Now what we're going to do is we're going to use that information to populate the Earth model. So we go into Earth model, populate properties. And if you were in the detect boundaries, you can just switch tab, just one tab to the right, and you get this menu. By the way, just to wrap up the boundaries discussion, you can also, if instead of trying to select them yourself, you already got them given to you. I know this happens sometimes. You can load them. You can just load them. You use these load boundaries from file, and it's going to ask you from where do you want to load them from. And you just have to make sure that the file looks like this. It's just as the numbers in text, the numbers that you're using with the units that you can specify the units. You can specify whether they're per physical or not. Like I said, just work with per physical, and they can be in true vertical depth, or they can be in measured depth. So either way, you can work with them. Now, back to populate properties. What we're gonna do here is we're gonna turn the logs that we have into the Earth model properties. So the first thing we're going to do is we're going to set up here. It's telling us that we need to set up 3 radial zones. So we're going to set up 3 radial zones. That makes the table expand. Now we have the borehole, 2 invasion zones, and then the uninvaded zone. For the borehole radius, we're going to use the radius that the log that we generated. Then for zone 1, we're just going to type 1 feet or 1 foot, I should say. These are just, I'm just reading along here. And for the second zone, it's going to be 3 feet. These are just your best guesses. And we're going to populate resistivity, which you can do here. And it's going to be using the same logs that we plotted. So it's MOR1 for the first zone, then MOR3, and MOR9 for the formation zone. Now we have the radius of the borehole, zone 1 and zone 2. And everything's populated. We're going to also populate gamma ray. To do besides the properties that you already have here, you can right click on the table, and it gives you this menu where you can select other properties that are part of the Earth model. So we want gamma ray, which is in the nuclear group, nuclear gamma ray. Now notice that gamma ray is only showing in the formation zone. That's because it's considered a petrophysical property, because it doesn't depend on the fluids in principle. So you only need to assign one value to the whole thing. Now resistivity, because it can depend on the fluids, it's going to have 3 different values, or you could even have 1 for the borehole. Right now we're not setting up anything, but if you know the resistivity for the mod, you would put it here. So we're setting up, we're using the gamma ray log to populate gamma. Now that we've done this, we just say populate properties. And it's so quick that, well, I did get a menu, but it was in my other screen, so you guys didn't see it. But it's done. It's also pretty quick. And now we're going to see the result of that. And we're going to see it as blocky logs, so the Earth model plots. So I'm going to start by gamma ray because it's the simplest one. Here, add another plot, another log. And instead of mnemonic, it's going to be Earth model and gamma ray. And I'm going to make this larger so it's easier for you to see what's going on. Don't care about this. So now you can see the gamma ray log, and there's this other blocky log. I'm going to make the layers a little thinner so that they don't get too much in the way. And I'm going to make the gamma ray. In general, I think the Earth model looks better. I'm going to use black. I think it looks a little better. And you can already see it, but if you zoom in, it's a little more clear. It's just taking some values for the gamma ray. What we have right now, it's just one algorithm. Yesterday during the closing remarks, some people were suggesting to have more than one algorithm for this, and we might do that at some point. But the way it works is it checks all the information that you have within that layer. Oh, so it takes all the data that log has within that layer, and if it finds a clear maximum or a clear minimum, it takes that value. So in this case, it's taking this maximum. In this case, it's taking that minimum. And if there's not such a thing, it takes the average, which is what it did in this case. And in general, it's a pretty good first approximation. It's pretty close to what you would find in the middle of the layer. That's, for example, that's another alternative, to take just the value in the middle of the layer. And it's your first order approach of turning these continuous logs into these piecewise discontinuous blocky logs that represent the Earth model that we believe is a better representation of the formation.
Excuse me, what happened here? Did you add the block log for gamma ray here? Just
yeah, to add that plot, you first, so I'm going to remove it and then I'm going to play it again. You first here in track number 2 plots, this is where you add the plots. I don't know how to. Sometimes people have a hard time getting used to it, and we may have to make these icons bigger. I don't know how to make it better, but this is where you go. We'll have to rethink about that. Just add log, and then in type, you're going to select Earth model. And in property, you have a lot of properties too. And in property, you select gamma ray. And you can change the color. Now it's black. You can change, well, and we want it to have the same limit, so 0 to 300 is fine. You want to make, sometimes I like to see the Earth model a little darker. Maybe this, if you use the same green, but not darker, but thicker, it's a little more clear. It's more matter of taste. This works for me. Now we did it for gamma ray, and I think it's pretty clear. Any questions? Comments? All right.
Joaquin, so these properties are from the formation, I mean, from the uninvaded zone, right?
Right. So because gamma ray is assumed to be petrophysical, it's assumed that the invasion is not going to affect it. So for gamma ray, it doesn't matter. For resistivity, it matters. And that's why for resistivity, we had to use 3. And now let's plot resistivity. And you're going to see how that makes a difference. So here we have the resistivity plots. We have the 3 of them, and we're going to add, for each one of those, we're going to add the equivalent Earth model. So the first one is going to be Earth model, or the one we used for populating it. So Earth model and then resistivity, parallel or homogeneous. And by default, it goes to the formation value. But let's see first the invaded. And I'm going to try to make the same color. So this was red, or what looks red to me. And then this is red. And I'm going to make it a little thicker also, so that it's more clear. And the boundaries, I'm going to hide them just so that it's even more clear. But I'm going to make them thinner. You can see that they get in the way sometimes. Some people prefer to keep them just in the very first track. Sometimes, I mean, again, a matter of taste and a matter of what you're doing. Sometimes it's useful to see them right there. Sometimes they get in the way too, for sure.
Okay, and in your experience, do you think it's reliable to include in this invasion model density and neutron logs?
Well, it depends what you want to do, but
I mean, if we have let's assume that okay, we have more than within the radius of investigation of these tools. Let's say we do have a boundary there of invasion, but my concern is that maybe we don't our inversion model or the sensibility of the measurement is not accurate enough for, even in this case, we apply that kind of restriction. Do you think do you have any case that these logs were used in this way?
right, yeah, you're right. The depth of investigation for those tools is not going to be enough for that. So yeah, in that case, probably it's not going to give you a lot more information. Yeah, all the projects that I've seen where invasion is tied to multiple logs, it's always resistivity.
Okay,
so
thank you.
Sure. Yeah. Now so we added for the first invaded zone. Now let's add the second invaded zone, which looks like that. and it's MOR3, which I use this this green kind of color, or bluish. And that's closer. So notice there's an annulus effect in somewhere here. And then let's add the last one, which is going to be the formation. And it's this one, which is orange. So I'm just going to do orange. And now we have the full model. You can see how this is very, very interesting. Anyway, you can see how it matches along the well, how it was populated. Now, what we're going to do, the next thing we're going to do is, there's another well, there's another way to see this. Now in point 8, it says the well interpreter has other, well, you saw the blocky logs, resistivity track, match the blocky log colors to a corresponding and gamma ray resistivities. We did that already. Now there's a different way to seeing resistivity in different invasion zones. So we add a 5th track, and we're gonna use the cross section, the cross section plot, which is this one. Add vertical cross section, the one that has 4 colors, and it looks like that. And by default is resistivity, because it's like Gabriel was suggesting, is the property that you would use the most for invasion. And it looks okay, but we could improve the coloring and we could improve a number of things. So for example, the scale, instead of being linear, we can change it to logarithmic, and we can see a little more contrast between the colors. Then the property limits are from 0 to 10,000, but the vast majority of the things that happen is up to 1,000 or even 100. So if you put it up to 1,000, you see a little more contrast. It's becoming more interesting. Maybe 100. It's closer to what we want to see. You can really see the contrast between the borehole and the rest of it, and you can see the areas that really have a different. Maybe when you go to 10, it's useless, because everything above 10 is going to be yellow. So maybe you can play with this and see whichever looks better to you. This 80, 0 to 80 looks fine. You can make it 1 to 80. It's a very small change, but you can make it a little different, 3 to 80, whatever you think is better. You can change, just for visualization, you can change the colors that you use. By default is this blue to yellow. It doesn't have the full color spectrum, but I think it shows the contrast better. MATLAB used to have these as the default color, and it used to be our default colors too, but blue to red, it looks like, I don't know, I prefer the other one. And again, a matter of taste, and there's many color schemes that you can use. I'm just sticking to the default. And then in some cases for invasion, it might be interesting to see the scale as logarithmic for the radius of, for the radius. 0.1 to 45, and maybe if you make it logarithmic, it looks like that. For invasion, it might make the grid look more uniform. I'm going to keep it linear. It's more physically realistic. And then you can change the units. Some people prefer to see these as inches. You can show the grid lines if you think that's useful. You can also hide the boundaries, so on. And now you can see also that the borehole, if you make the limits, I'm going to see the closer limits. You can see that the borehole is not uniform, because we use the radius. So there might be washouts here, and so on. And you can also reset the limits just by clicking here to what the software thinks is a good starting point. And I think that's it. I don't know if we have any questions or comments. This is it for this exercise, and that's what we have for the. We're going a little too fast. This is what we have for the morning.
I think that's okay because I think the next one, we only have an hour set up and it might take a little bit longer. So I'm going to bring the nuclear sim into my part.
Okay, so we have a couple of options. I'm going to stop sharing, by the way.
Sorry, a quick question. On setting the resistivity limit, I was trying to set the limit for visualization, and I have like 0.3 to 300. How do you change that? So you have like 1 to 1000, right? How do you change this limit here?
Yeah, so the way you change that limit is here. You have the scale logarithmic. That's what you did, right? And then there's 3 controls that control the limit. You go from the left offset, which is, in this case, I'm using 1, but you can change it to whatever offset you prefer. It's just because the lines need to be consistent across all the logs. So you have the offset
okay.
the same for all of them. And then the number of decades, because of the same reason. So those 2 controls are going to apply to all of them. And then each individual plot can determine its own left limit. So it can be 1 or 10 or 100. I just made it 1.
Oh, okay.
So yeah, so if it was just 1 plot that you were working on, it would be easier to have them. You would be able to explicitly say, okay, I want the left limit to be 1 and the right limit to be 1000. But because it has to be consistent across all of them, you have this a little more convoluted way to set them up.
Okay.
Good. All right. Well, okay. Let's see. Is anybody brave enough and able enough to reach this point that wants to share their final results? Do we have any volunteer? Otherwise, we can move on to the next section. All right. Well, so Bruce, you were saying that for the next, it's okay. So it's 11:20 right here. We can either take like a 10 minutes break and have like a 30 minutes for you to start, and then we go for lunch and come back. Or do you all prefer to take a longer break right now, even though it would mean early lunch or dinner or whatever?
Ten minutes is fine for me.
10
I
minutes?
don't know about anybody else.
Yeah. Bruce?
Yeah, that's fine. I mean, I can do a half hour before lunch. I mean, I guess if we want to keep the schedule closer to what we have written down.
Yeah. Okay, in that case, let's take a 10 minutes break and come back at what is 11:30 in US Central.
Okay, and then we'll go from 11:30 to 12 and then take the break, and then I'll continue on from 1 to 2 then.
Yep, sounds good. All right. So see you in 10 minutes.